Hi, this is Mrs. Matasevich, and this is your homework on prime factorization. And we're going to do factor trees first. It's your 13.3 homework. So let's read the question. For the following two problems, complete the prime factorization tree by filling in the boxes. After that, fill in the box below the tree with the prime factorization for the number. Note, click on the box to enter the number. Okay, I'm not going to be doing this because I'm not using Google Slides. I'm using a different program. But I'm going to first complete factorization tree. So I have 66. 66, I'm given here 6. So 6 times which number is 66? If I cannot do this in my head, I can also go and divide 66 divided by 6. And it's going to be 1 times 6 is 6. Now I take 6 down, and then 6 goes into 6 one time. 1 times 6 is 6, and 0 remainder. So if you don't know by heart 6 times which number is 66, I can divide 66 by 6, and my answer is 11. So I'm going to write down 11 as my answer. So 6 times 11 is 66. In the left box, I have 6, and 6 is a composite number because I can split it into two different numbers, into two factors. And 6 is 2 times 3. So now 2 is a prime number, and 3 is a prime number. So this is prime factorization. I cannot keep going, and 11 is a prime number. So 2, 3, and 11 are prime numbers. And this is it. Now I'm going to take these numbers and copy them down, because the second part of the question was, after that, fill in the box below the tree with the prime factorization for the number. So you're going to write this prime factorization. So this 2 is going to go here, 3 is going to go here, and 11 is going to there. The order doesn't really matter, but it's always a good idea to start from smallest, which is 2, and then times 3, which is next one, and then times 11, which is the next one. Because when we're going to be looking for the greatest common factor, then it's much easier to find it when your numbers are lined up from least to greatest instead of they're all mixed. So this is prime factorization of 66. The next one is prime factorization of 81. I have to separate 81 into two factors, and I'm expecting that each factor has another two factors. So I have to put two composite numbers, because if I put a prime number here, like 3, then I'm not going to be able to do factor tree underneath 3. So I have to put two numbers here that both composite. And many of us know times table is 9 times 9 is 81. So 9 times 9 is 81. Now in this next step, I'm thinking 9 can be split into two which factors, which two numbers I can multiply to get 9. And that is 3. And this is 3. So 3 times 3 is 9. If I'm going too fast, just pause the video and catch up with writing. The next number is also 9. So I'm going to have the exactly same two numbers down underneath, which is going to be 3 times 3. 3 is a prime factor. I cannot split 3 into any other numbers. There are no smaller numbers that can divide 3 except 3 and 1, and 1 is not a prime number, so we're not interested in 1. So these are prime factors of 81. Remember, this is prime factorization, and 1 is not a prime number. We do not put 1 into any of these boxes. Neither we can put 9, because 9 is a composite number. You can take 9 apart. So the only numbers that go here are prime numbers, and in this case, I have 4 3s are my prime numbers. So my prime factorization of 81 is 3 times 3 times 3 times 3, and that is 81. So again, in prime factorization, when you write the prime factorization, you cannot have 1 or a composite number. They have to be prime numbers. Now we're going to continue with the next slide, which is simplifying fractions. So the question says, perform prime factorization in order to simplify the fraction in the two problems below. So perform prime factorization. So I have to do prime factorization of 12 and prime factorization of 42. I'm going to do prime factorization of 12 here above. So 12, I can split it in 6 times 2. And then 6, I can split into 2 times 3. Instead of going 6 times 2, I could have also had 3 times 4. I would still get the same prime numbers. So my prime numbers, I'm going to circle them at 2, 3, and 2. And those numbers, I'm going to put them down in as prime factors of 12. So I have 2 2s and I have 1 number 3. So this is prime factorization of 12. The next one, I have to do prime factorization of 42. Please pause the video and copy the notes. So my 42, I'm going to change colors so they don't mix. So 42, you can go 2 times 21. You can go 3 times 14. I'm going to go 6 times 7 because that's something that most of us know just from a simple times table. 6 is a composite number, and it's going to be 2 times 3. 7 is a prime number, and I'm done. So 2, 3, and 7 are prime numbers. We cannot do anything with them. We cannot take them apart. So it's going to be 2 times 3 times 7. So this is prime factorization of 12 and 42. Please note again, you do not see any number 1. There are no 1s here because 1 is not prime number, and you don't see any composite numbers. They're all prime numbers. Now we're going to circle common factors between 12 and 42. I'm going to use a little bit thicker pencil. So I can see 2 is a common factor and 3 is the common factor. They exist at the top and at the bottom. What we have to put here is the greatest common factor. We can do simplifying fractions in many different ways. We could just simplify it right here, but this problem is asking us to write the greatest common factor here and then whatever is left there. So my common factors are 2 and 3. So 2 times 3 is 6. So my greatest common factor is going to be 6. I'm going to put 6 here, okay? So 2 times 3 is giving me 6. And now this 3 and this 2 are giving me 6. If I would not get 6 over 6 here, I would not have giant 1. So this has to be the same number in the top, the numerator, and the bottom. So this is giant 1. Because 6 divided by 6 is 1. I can eliminate this. 6 divided by 6 is 1. Now we're going to see what's left. 2 was not simplified. It did not disappear. So 2, we're going to keep it. And we're going to write it here. That's what's left over. And then also what's left underneath is 7 because 2 and 3 are gone. So 7 is left. So I'm going to put 7 here. 6 times 2, sorry, this is not 6. 6 over 6 is gone. So this is 1. 6 divided by 6 is 1. 1 times 2 sevens is going to give me 2 sevens because 1 times any number is going to be the number itself. And my answer is 2 sevenths. To check if my answer is correct, I can check if 2 and 7 are prime numbers. Yes, they are. Or if they have any common factors. They don't have any common factors, so I'm done. 2 sevenths is a simplified version of 14 over 12 over 42. So 12 over 42 and 2 over 7 are equivalent fractions. They have exactly the same meaning, they mean exactly the same quantity, but they look different. The next problem is 56 over 70. So we're going to do prime factorization of 56 and prime factorization of 70. I'm going to do this above here, 56. All these prime factorization you are doing in your notebook or scratch paper. I'm doing it here so you guys can see all the work on one sheet of paper. So 56, I can go 7 times 8 is 56. That's what timetable teaches us. And then 8 is 2 times 4. And 4 is 2 times 2. Now I'm going to check if I can take apart any other numbers. 7 is a prime number, so I cannot do anything with 7. 2 is a prime number, I cannot do anything with 2. And these two are prime numbers, I cannot do anything with these 2's. I'm going to take these prime numbers, 7, 2, 2, 2, they're my prime factors, and I'm going to copy them down here as prime factorization of 56. It's going to be 2 times 2 times 2 times 7. So this is prime factorization of 56. In the next step, we're going to do prime factorization of the denominator, which is 70. So I'm going to write 70 here next to 56, and I'm going to do prime factorization of 70. Probably the easiest way to go is 10 times 7, because I see 0 at the end, so I have to be able to divide by 10. And 10 is 2 times 5. My prime factors are 2, 5, and 7. I'm going to take 2, 5, and 7, and I'm going to copy them. So 2, 5, and 7, I'm going to copy them down below because they are prime factorization of 70. So it's going to be 2 times 5 times 7. So now that we have prime factorization of 56 and 70, I'm going to be looking for common factors. I see 2 in the numerator and in the denominator. So I'm going to circle 2 and 2. It doesn't matter which 2 I pick, the left one or right one. Doesn't really matter, or this one. I just went to the closest one. So it's 2 over 2. And the other one is 7 over 7. So these are my common factors. Now I'm going to multiply my common factors. So I'm going to go 2 times 7 is 14. And the other 2 times 7 is 14. And we're going to look what's left. In the numerator, I have 2 times 2 is left. So that's going to be my leftover that I'm going to put in the second part of my fraction. It's going to be 7. And then at the bottom, I have 5 left. So 2 and 7 are common factors, but 14 is the greatest common factor. And the greatest common factor is what gives me my giant 1, ultimate giant 1, even though 2 over 2 is also giant 1 and 7 over 7 is giant 1, but 14 is the greatest common factor of 56 and 70. Again, this step we can skip and I can just go and divide 7 by 7 and 2 by 2. Or you can just add this step. It really, there is no difference, however you like it. But in this homework, we had to show it because we had space left for the greatest common factor. So 14 divided by 14 is 1. That's my greatest common factor. And what's left is 7/5. So my answer is going to be 7/5. 7/5 and 56 over 70 are equivalent fractions. Again, they mean the same quantity, but they just look different. Thank you, and now you can complete your homework if you did not do it first time.